Right, good afternoon and welcome to this kinematics series. Now, while we talk about uniformly accelerated motion, I think one of the important graphs we have studied is VT graph. But our concentration should not be VT graph. We should also concentrate on the position versus time graph. So, we have three things to play with. One is velocity, second is position, third is acceleration. So there are two important graphs. The second category of the graph in kinematics is XT graph. So if you see, we are studying uniformly accelerated motion, and this graph represents position versus time for a uniformly accelerated motion. So essentially, you can see the shape of the graph is parabola. If you're not a math student, you would not know it's a parabola. So just take it with a pinch of salt that this is a parabola. The mathematical equation, which is the equation of motion, is the first equation of motion which is equivalent of this. So v is equal to u plus at and s is equal to ut plus half at square. I think this is the second one, not the first one. So the position and time are linked to each other with this equation, and if you plot a graph of s and t, what you will get is a parabola. Okay, so I know it's a bit of mathematics, but by the look of the figure you should be able to ascertain that if the position versus time graph is a parabola and you have a t square in the equation and a t, so if you have t square, this is definitely a uniformly accelerated motion. If you have t cube, t4, it's not a uniformly accelerated motion, because the maths for uniformly accelerated motion is fixed to be this equation. Thank you very much.